So let's try to draw all these concepts together now and think about it within the context of resilience. I've talked about natural systems, and now we're going to switch to what we think, how we can apply this concept within reclamation. So reclamation strives to move a system from an undesired state to a more desirable state. Resilience thinking now, however, is a major departure from the conventional approach to natural resource management, which is typically focused on maximizing one or a small number of ecosystem services, for example, wildlife habitat, or goods, often timber volumes. A focus on resilience means that our reclamation should also seek to restore natural processes. So rather than end products, we need to focus on process as well. Now this approach, the resilience approach, has two important virtues. First, reinstating natural processes requires less ongoing human management. If we have processes functioning well, we worry less about the system and what's going to happen to it when it does incur disturbance. And at least equally important, restoring natural processes will allow ecosystems to evolve over time just as they did before the occurrence of mining. So processes are essential. We tend to focus on end products, and we tend to ignore processes. And I'm going to develop that point a little further in a few minutes. So applying the concept of resilience in natural systems is to pose the question, how much can self-organization capabilities be perturbed and still achieve desired outcomes? In other words, what can we take away from a natural system and still have that system function in some way that we think is desirable? In reclamation, the question is, how much of the self-organization capabilities of a system must be created to achieve desired outcomes? So there are two very different questions. We can begin to address the significance of this distinction, again, by returning to our metaphor. What I've shown you here in the upper panel is the ball and cup metaphor for a natural system. Remember, we talked about the fact that the ecosystem trajectory will move within this particular state space from here to here. And at some point, it will get moved back by disturbance. And assuming that disturbance is not beyond the resilient capability of the ecosystem, that will continue to perpetuate over time. Now what we do, the big difference in natural systems is, of course, we have a historical legacy here. That historical legacy is very important. It constitutes the seed and propagule bank, the amount of litter, coarse dead organic matter, and nutrient capital that accrues on the site and has accrued over a long period of time. That historical legacy cannot be ignored in natural systems. It's an extremely important part that provides considerable resilience to these systems. In other words, it helps to keep the system within this stability domain. Now remember, it's also possible, however, that with sufficient disturbance, you can move the ecosystem into a different stability domain. And that's when the resilience of the system is exceeded. So let's look now and contrast that to natural systems, to reclaimed systems. The situation begins very differently. We put a soil cap down, which in some respects is supposed to represent historical legacy in some way, shape, or form. That's our effort to try to begin to create that legacy. The problem is that if we don't do anything with that system, it's highly unstable in the sense that the system could move and get pushed into one of a number of different stability domains. And that's the problem with reclamation, is we need to establish the system in such a way that it moves into a stability domain that we consider to be desirable. And so we try to do something about it. And essentially, we put a series of planting prescriptions in. We might do an LFH amendment. And the idea here is we're trying to, in some way, simulate or restore in any way, shape, or form that historical legacy. And the idea being that We then want the system to move into this stability domain to create some sort of end, to achieve some sort of end land use objective that we think is desirable. So that's a fundamentally different way to think about reclaimed systems relative to natural systems. And it puts into perspective why we do what we do in reclamation. So how do we build resilience into reclaimed ecosystems? Well, there are three things we can do. We can reduce the stress on the system, and we can increase its buffering capacity. We can manage for processes, and that should be done at multiple scales. And we can remove barriers to alternative thinking about resilience and to approaches to resilience. And I'm just going to briefly detail that in a moment. Let's return to our metaphor. What I've done now is express this, the ball and the cup metaphor in 3 dimensions. Now, imagine that this is a reclaimed ecosystem. But the point being that ecosystems that are rich in organic matter and nutrients tend to have higher resilience. Connectedness through diversity of function increases the ecological capital of nutrients and biomass. So we know 2 things then. We know if we're rich in organic matter and nutrients, and if we have connectedness, the chances are we're going to build resilience. Now let's try and understand what that means. So what you see here is this space. The blue ball in the middle represents the starting condition in reclamation. And as I said earlier, if we don't do anything at all about this ecosystem could move off in any one of 7 different directions. So if we do absolutely nothing, change will occur. It's just not necessarily the change that we want to see. We could build buffering capacity in a number of different ways, but here's how you think about buffering capacity as the depth of the channel that ball might go down. The deeper we dig the channel, the harder it is for that ball to get moved out of the channel. So that ball might be moved by disturbance events that enter the system. You can think of the ball sort of jumping out of the channel. Obviously, the bigger the disturbance event, at some point, it will shift to a different state space. It will move in a different direction. But with reclamation, we're trying to ensure that it stays within a particular direction. Now, I've drawn this in a fairly linear fashion, but that's really not the way to think about this. These systems follow what we think of as trajectories, but those trajectories are not necessarily predictable in a strict sense. What we want to do is make sure the ecosystems retain functions and processes and attributes that we consider desirable. Now, I've added another set of arrows in here, and those constitute stress. So what happens with stress, and I'll give you an example of this in a minute, stress tends to push these ecosystems laterally. So they'll move the ecosystems all out of this channel. They tend to do it in a kind of a consistent fashion, as opposed to a single disturbance event that sort of jumps the ball out. Stress tends to push the ball gently out of the channel. Notice that stress early on can have an easier time of moving the ecosystem into a different state space than stress later on. So that's something else to think about. Ecosystems are particularly vulnerable to change during the earliest stages of reclamation. Examples of stress are available nutrients, moisture, salts, and acids. So ecosystems that are low in nutrient availability, that incur moisture stress, that have salts incursion, that have acidification, ferment deposition, those are all stresses on the system. Those stresses can move that system outside of its ability, its resilience capabilities. Buffering capacity is built by nutrient pool size, available moisture holding capacity, propagule banks, diversity within functional groups, and live and dead structure. All of those confer buffering capacity. So any reclamation prescriptions that tend to reduce stress and enhance buffering capacity will in fact favor resilience of that particular ecosystem. Building resilience also means managing for processes at multiple scales. This is critically important. I talked to you earlier about how we could consider resilience from the perspective of a particular seral stage. So for example, we might say, how resilient is a seral stage to all of the processes that are driving change? How stable is that particular seral stage before it transitions to something else? And I pointed out to you that, in fact, you can think of resilience as not just a single seral stage. You can think of it as a whole process of sequential seral stages. That's a temporal component to resilience. But there's a spatial component as well, and that's illustrated here, that what happens in the upland affects what happens in the wetland. And that's one thing we don't typically consider yet, is the fact that, ironically, the greater success we have in building resilient ecosystems in uplands could negatively impact the resilience in wetlands because of moisture interception and evapotranspiration. That means there will be less water available in lowland systems. It suggests then, and what it does is indicate that, in fact, resilience has a spatial component as well as a temporal component. So let's talk about barriers to resilience. How do we manage for resilience and reclamation? We need to overcome several barriers. I've identified 4, but 2 of them are really sub-barriers. There's a conceptual barrier we need to think about, a barrier for paradigms, and then psychosocial and regulatory barriers. We shouldn't ignore any of them. The conceptual barrier is that resilience requires consideration of structure and scale. And the slide I just showed you is an example of that. We have to think, you cannot think of resilience as just a single area, a single space in time. You have to think of it in a much broader context. So structure refers to what's there and in what amounts. I suggested keystone species, population, ecosystem attributes, and processes are all aspects of structure that we need to think about in our reclamation plans. Scale pertains to both space and time. Properties that confer resilience are not independent of the spatial scale under consideration. And resilience has no context unless we answer the question of over what time scale do we consider an ecosystem to be resilient. Now, many who work in the resilience space consider 2 centuries as being an appropriate time scale for resilience. The reason is that disturbance regimes occur over long time frames. We can have short time frames for particular disturbances, but other disturbances occur on much longer time frames. Our resilience definition needs to accommodate the fact that disturbance regimes occur at different temporal scales. So I've illustrated then the fact that there's time, structure, and space require all consideration of resilience. There's a paradigm barrier we need to think about. Resilience is a concept that describes a more complex model of ecosystem management than the traditional resource management paradigm, which focuses on maximizing social uses under achieving prescribed resource outputs. So we have this tendency to say, well, we want to manage for things like timber volume or wildlife habitat attributes or some sort of single objective. Resilience requires that you think broader than that. We cannot manage for a single objective because it tends to destabilize systems when we do. And there are plenty of examples in the natural resource management space to illustrate that point. And to some degree, though this paradigm is permeated, the tools and the approaches that we've already taken in oil sands reclamation. In uplands reclamation, for example, the core approach is to define an end land use objective and then apply the appropriate planting prescriptions. Not enough consideration is given to how that ecosystem will reach its end state or the prospect for doing so. We have a series of manuals that we follow where essentially we have a definition of where we want to go. We decide early on what we think we want to do to get there, but that's about all we give in terms of consideration. In a resilience approach, you have to focus much more on the processes that drive ecosystems forward, that underlie self-organization. Manuals and practices, as another example, for uplands and reclamation are distinct from wetlands reclamation, despite the fact that the two are independent. From a resilience perspective, you cannot ignore the fact that they're interdependent. You have to deal with them on different scales. It's a hierarchy that you need to consider and should be part of the planning process. Just to summarize kind of a management-oriented or a target-oriented versus a resilience-oriented approach. The management-oriented approach focuses on targets. Where do you want to go? Resilience focuses on processes. What process targets do you have? Not so much what the end objective is. Management focuses on a narrow scale, whereas resilience forces you to think in a broader scale, from stands to landscapes, sub-watersheds, etc. Management tends to be very specific and focus on target tree species, for example, whereas resilience focuses on diversity, particularly with a particular emphasis on keystone species. There's no reason why those keystone species can't be trees, as I've indicated, but they're not only trees. Management tends to try to avoid change. We try to manage to avoid these changes in the system. We want it to follow some sort of deterministic trajectory. And so another point there is the constancy of relationships. We sort of expect that things will change at a relatively constant rate over time, and we set some end land use objective that we're going to achieve over some particular time frame. That's probably not realistic. And in terms of management-oriented, it's reflected in our best management practices. By definition, what we suggest is, well, this is what we can do, this is the best we can do at this time, and as long as we do this, the system will move along to achieve its end use objective. All of those are different when you consider a resilience approach. You have to accept that change will occur. The relationships are dynamic. They don't occur at a prescribed rate. Sometimes disturbance is necessary to move change along, whether it's natural or human. There are uncertain outcomes, and the approach should be much more around adaptive management. Best management practices should be considered more as hypotheses, subject to test. And if they don't work the way we are anticipating, if they don't drive the processes that we think are important for resilience, we need to change them. So in that respect, there is really no such thing as a best management practice under resilience thinking. And finally, there are institutional barriers, what I call psychosocial and regulatory barriers. And I'm only going to discuss these briefly because Brett will talk about barriers later. Psychosocial barriers include an inability to accept the unpredictability of complex ecological systems, and driven by the myth that disciplinary science will resolve most uncertainties of management. It's a common refrain that if we just had more data, if we just had more information, we'd be able to do this better. We can't seem to get our minds around the fact that these systems are inherently, in a sense, unstable, but they're unpredictable. Nature is not deterministic. It moves in directions that we cannot easily predict. All we can do is build in the capacity for change that matches outcomes that we think are reasonable and desirable. So related to this then is the tendency for humans to discount the importance of future events. We all do it. Climate change is an example, but the eventual rise in interest rates is another example. We're still spending as if interest rates aren't going to rise. I do it. We have this inability to think about the future. We discount the future. And it's a huge issue because it's not what's going to happen next year or 10 years from now that's really important. It's what's going to happen 20 and 30 years from now. And we're able to somehow absolve ourselves of responsibility for having management practices today that would account for the issues that our children need to resolve. And there are regulatory barriers as well as those psychosocial barriers. They derive from both the psychosocial barriers, that's why you can't ignore that, but its roots are in the traditional resource management paradigm. Examples of this include a reliance on best management practices. Seed zone restrictions are another example of regulatory barriers. Now they're being broken down, we are seeing changes in that. But typically in the past, historically, We put restrictions on what material can be moved in and out of a particular system. The objective, the idea being that locally adapted species must be the best species to use going forward. We now know that with changing climate conditions, that's not the case. So that's a regulatory barrier that needs to be overcome. Species selection limits are also the same issue. And there's a focus on deterministic and prescribed outcomes, which we probably need to revisit. That's not to say that we should not have end land use objectives. It's not to say that at all. We obviously need to know where we want to go, but we have no idea if we're moving along that trajectory. The point is we need to change the focus and emphasis as much away from these end use objectives that are typically oriented towards products, commercial forest being one of them. And we need to focus more on processes. What are the processes that help these systems cope with the changes and the disturbances that they're going to be subject to?